Morning, dear students. Yes, so in the previous class, we have started with the chapter Amines. So did you understand? So we have discussed about what are amines. Then we have discussed what are the classification of amines. Then we have seen the nomenclature, right? Then that is how we name the amines. Then we have discussed the structure of amines. Then we had started with the preparation of amines. So out of six preparations, so we have seen two preparations, right? Okay. So the first preparation was what? From the reduction of nitroalkanes, that is compounds. What is reduction? Reduction is nothing but addition of hydrogen. Okay. Fine. So we were discussing the preparations, right? So what are the different preparations which we have seen yesterday? So first was the by reduction of nitro compounds, right? By reduction of nitro compounds. So how is the reaction proceeding? So we have nitro compounds, okay, and we do reduction. Okay, so what we are going to do, we are going to add hydrogens. Okay, so this will go in the presence of tin HCl, or you can take FeHCl, or you can put hydrogenation, that is catalytic hydrogenation, that is H2 hydrogen in the presence of nickel, platinum, or palladium, right? So what you are going to get, you are going to get amine. So your oxygen O2 will be replaced by H2 plus 2 H2O. So you get a primary amine. So this was the first preparations which we have seen by reduction of nitro compounds. Okay. Then the second preparation method of preparation was what? By reduction of nitriles, right? By reduction of nitriles. So what are nitriles? Nitriles are nothing but the cyanides. Okay, C triple bond N. These are cyanides. So what we are going to do? We are going to take nitriles. Again, we are going to do reduction. How we are going to do reduction? In the presence of either lithium aluminum hydride. So lithium aluminum hydride is a good reducing agent. Okay, it is a strong reducing agent. Or you can use sodium amalgam in alcohol. So either of this you can use, or you can go for a catalytic hydrogen. Or you can use catalytic hydrogenation. So these are the, so what we are going to do, we are going to nitrize. Okay, we are going to add hydrogen. We are going to add hydrogen in the presence of what? H2, in the presence of nickel or palladium or platinum, or you can use sodium amalgam in alcohol. Okay, or you use, or it is okay, or you can use lithium aluminum hydride. So you can use any one. And across this triple bond, what is happening here? You are going to add hydrogens. So four hydrogens are there, two hydrogens are added here, hydrogens are added here. So you get RCH2 and H2. Okay, RCH2 and H2. So these, what you're going to get, you're going to get a primary amine. Okay, so these two preparations we have seen in our last class, right? So let us proceed with the next one. Okay, so the next is by reduction of amides. Okay, next is by reduction of amides. So let us see. So next is by reduction of amides. Third preparation by reduction of amides. Okay, so here what we are going to take? We are going to take a acid amide. We are going to take a acid amide. So which is acid amide? C double bond O NH2. Okay, so this is the acid amide. So acid amide, we are going to do again reduction. What we are going to do? We are going to we are going to do reduction. Reduction means what? Adding of hydrogen. Okay, so here we are going to add hydrogen in the presence of lithium aluminum hydride, and or you can use otherwise sodium in alcohol, or you can use other reagent which can be used is sodium in alcohol followed by hydrolysis. Okay, followed by hydrolysis will give you what? You will get a amine. Okay, you will get what? You will get the amine. So this is the reaction. So let us see. So what? So amide is there. Okay, this is an acid amide. So acid amide, what we are going to do? We are going to do reduction. Okay, we are going to do reduction. How we are going to do reduction? In the presence of lithium aluminum hydride followed by hydrolysis. Okay, so what we are going to get? RCH2 NH2. Okay, plus water. So what we got primary amine. Okay, we got a primary. Is it clear? Is it clear? This particular preparation. So we are preparing amines. Okay, we are preparing amines from different starting reactants. So we are taking different starting reactant, and from those starting reactant, we are going to do. We are going to prepare alcohols. Okay, sorry, amines. Is it clear? So let us say example. For example, just take one example. Okay. So here, going to take acid amide. Okay. Acetic amide. So this is our acetic amide. So this we are going to treat it with what? We are going to do a reduction followed by in the presence of lithium aluminum hydride and water. Can anybody tell me what will be the product? Yes. What will be the product here? What will be the product? CH3, CH2, and H2, right? So it is CH3, CH2, and what is the name? What it is a plus water. G CH2, H2, yes. Wherever we are considered as ethanol, okay, you are going to get a ethanol. So this is the next preparation. Yeah. So we have answered. Very good. Okay, so this is the next preparation, that is by reduction of amides. Okay. So let us go for the next important name reaction. Yes, ethanol. So next, so these are the three preparations. So next is a very important name reaction. Very, very important. Okay, asked for exam. So the next important name reaction is our Hoffman. So mark this as important. Hoffman bromamide. Hoffman bromamide degradation reaction. Okay, degradation reaction. So this is a next name reaction. Okay, Hoffman's bromamide degradation reaction. So here what we are going to do, we are going to take amides. Okay, again we are going to take amides. Okay, so acid amides. So these are what? These are acid amides. So these acid amides, we are going to treat it with bromine. Okay, we are going to treat it with aqueous bromine. Okay, we are going to treat it with aqueous. Either you can take a aqueous bromine or you can take ethanoic bromine. Okay, sorry, aqueous bromine. Okay, we are going to take aqueous bromine. We are going to take aqueous bromine. Okay, or egg, and ethanolic, ethanolic NaOH or KOH. Okay, you can use. So this is the first reagent which is used, that is aqueous NaOH, that is aqueous bromine. Okay, we are going to take aqueous bromine, then or we are going to take ethanoic NaOH or KOH. Okay, and what it gives you? Primary amines. Okay, it gives you primary amines. So acid amines, we are going to take bromine, plus we can take NaOH, we can take KOH. Ethanoic means it is prepared in ethanol, okay, in alcohol. So NaOH, KOH is prepared in ethanol. So we are going to get what? We are going to heat it. So we are going to heat it. So acid amines, we are going to treat it with bromine in aqueous or and ethanoic which is your primary amines. Okay. Now, whatever the amines are prepared here, so it contains one carbon less. Okay. So you can see here there is one carbon here. Here there is no carbon. Okay. So here there are two carbons. Right. Here there is only one carbon. So in the product you can see one carbon atom is less. Okay. One carbon atom is less than the parent amide. And hence this is called as degradation reaction. Why degradation? Because one carbon is less in the product, right? As you see in the reactant, there are two parent in the this okay parent amide. You can see two carbon atoms, and in the product you can see only one carbon atom. So it is called as a degradation reaction. What it is called as degradation reaction. So this is a very important question. Ask this is important for marks. Okay, so again I am explaining Hoffman's bromamide degradation reaction. Okay, so how this will proceed? We are going to take acid amides. So acid amides are our starting reactants that we are going to react it with what? Bromine, Br2. Okay, that we are going to react it with Br2 plus we are going to react it with ethanoic KOH or you can take NaOH, that is sodium hydroxide or potassium hydroxide. Any of this we are going to take. Then we are going to heat it. After heating, what will happen in the product? What you can see one carbon atom less. So in the starting reactant, there are two carbon atoms. In the product, you can see only one carbon atom. So this reaction is called as degradation reaction. Degradation means the carbon number of carbon atoms are less, okay, as compared to the reactant. Is it clear? So what are the side products again? So RNH2, plus Na2CO3. So please copy it down. Very important. Name reaction. I would have written it down. Okay, so very important. So this is a name reaction. Is it clear? Okay, so let me give you example. So first we'll take a aliphatic amide and then we'll take a aromatic. Okay. So first one is acetic amide. So acetamide. So let us take acetamide. This is a what? Acetamide. Okay. This is our acetamide. Again, we are going to take it with aqueous bromine plus ethanoic KOH, or you can take NaOH. Then we are going to heat it. Yes. Tell me the product, students. Tell me the product. What will be the product? What will be the product? Okay. Yes. Very good. It is methanamine. Okay, not amide. It will be methanamine. Okay. CH3CHNH2. Yes, very good. So this will be CH3NH2. So one carbon atom will be less. So it is methanamine. It is methanamine, not amide, because we are preparing amine. Right. So amides we are preparing amines. So methanamine. And what will be the other products? Yes. So other products are what? Na2CO3, okay, sodium carbonate, plus 2NaBr and plus 2H2O. Okay. Okay, let me take one more example. So what is this compound? So this is a benzanamide. This is a benzamide. So benzamide, again, we are going to treat it with bromine in the presence of, now I'll take KOH. Okay, I'm going to take ethanoic KOH. So I'm going to heat it. I'm going to heat it. So tell me what will be the product? What will be the product? So I've taken benzamide. Okay, we have taken a aromatic amide. So aromatic amide is there. We are going to treat it with aqueous bromine, and we are going to treat it with ethanoic KOH, potassium hydroxide. Yes, students, what you are going to get? What will be the product? What will be the byproduct? Clear? Hoffman bromide degradation reaction, is it clear? So we have taken two uh, examples. One is with another was aromatic amides. Is clear both the reactions? So is it clear? Hoffman bromide degradation reaction. Okay. So let us go for the next one. So the next one is okay. Next one is ammonolysis of alkyl halide. So what we are going to do in ammonolysis, okay? So we are going to take a alkyl halide. Okay, so we are going to take ammonia. We are going to take ammonia and we are going to react it with alkyl halide. What is alkyl halide? RX. Okay, so what will happen? So at each step, okay, so until we have hydrogen, so at each step we are going to add alkyl halides. Hydrogen we are going to alkyl halide. Okay, at subsequent step, what will happen? One hydrogen halide will be released. So here what you are going to get R2NH. Okay, we are going to get a secondary amine. We are going to get what? Secondary amine. Again, we are going to treat it with what? Alkyl halide. Okay. Again, one HX will be left because one hydrogen, okay, one hydrogen will be combining with your X. So you get HX. So now we get R3N. So you get what? Tertiary amine. Again, we are going to treat with RX. Okay, so what we will get now? Quaternary ammonium salt. So this is a tertiary amine, this is a secondary amine, this is a tertiary, and this is a quaternary, quaternary ammonium salt. So this is the another method of preparation, okay, of amines. So what we are going to take, we are going to take ammonia. At each step, what is happening? One of the hydrogen is replaced by the alkyl. Okay, and your hydrogen is what is happening? It is combining with the X and it is removed. Okay, minus again first get primary amine. Then again we are going to treat it with alkyl halide. So what will happen? One of the hydrogen again it is replaced by your alkyl group. So you get what X door. Okay, this we get. Then again we are going to treat it alkyl halide. We get a tertiary amine. Again we get quaternary ammonia. Okay, ammonium salt. So we'll see one example. Then you'll come to know. Okay, so monolysis, let us see. Okay, so which alkyl will take C2H5Cl. So this is what it is. Yes, what will be the product? So you have to get what? C2H. Okay. So what will be the product? So we are going to take ammonia. We are going to treat it with alkyl halide. Okay. So what we are going to get? We are going to get ethyl alkyl halide. Okay. We have taken ethyl and we are going to get, so one of the hydrogen will get reacted with Cl and this is removed. Right. So this is our primary amine. So this is the primary amine which we got now. Now again, what we are going to do? Again, we are going to treat it with the alkyl halide. Okay. So at this moment, what will happen? So this is what? This is a ethylamine. The name is ethylamine. Okay. So again, one HCl will be because this hydrogen, okay, this hydrogen, what will happen to the hydrogen? It will get this hydrogen, what will happen to the hydrogen? This will get combined with the Cl. Okay. And you so you're going to get what? Diethylamine. Okay, diethylamine. So you get a secondary amine. You get what? You get a secondary amine. So this is a secondary amine. Again, what we are going to get do, we have one more hydrogen. So again, we are going to treat it with ethyl chloride. So what will happen? HCl will be removed out. And what we are going to get? We are going to get a triethyl alcohol. Sorry, triethyl amine. Okay, we are going to get a triethyl amine. So this is a tertiary amine. That is a triethyl amine. Okay. Now again, what we are going to do? Now we are going to take it with the again ethyl chloride. Okay, and we are going to get what? C2H5 4 N plus Cl minus. So this is a tetra. Okay, tetra ethyl ammonium, tetraethyl ammonium chloride. Is it clear? So this is a ammonolysis of alkyl halide. So this is a ammonolysis of alkyl halide. Is it clear? Right? So this is a ammonolysis of alkyl halide. So from this ammonolysis, what we are going to get? We are going to get all primary amine, secondary amine, tertiary amine, and quaternary ammonium salt, depending upon how much alkyl halide you are supplying. Okay, how much moles of alkyl halide you are supplying. So if you are supplying only 1 mole of alkyl halide, you are going to get primary. If amine, if you are going to get, if you are supplying 2 moles of alkyl halides, you are going to get what? Secondary amine. 3 moles tertiary. If you are supplying 4 moles of quaternary ammonium salt. Okay, so this was another name reaction, very important name reaction. Okay, is it clear? Yes. Shall we proceed further or you want me to explain it again? Is it clear? Okay, fine. Can you tell me here what will be the product? So C6H5, CH2, NH2. So we have a ammonia. Okay, we are going to read it with the amine. Okay, so what will be the product? We are going to get what here? Let's just take it down. C6H5, CH to Cl it is. Okay. So what find with the Cl and we are going to get what? This is a name. We are going to get a benzylamine. Okay, we are going to treat it with 2CH3Cl. Okay, 2 moles of alkyl halide. Then what will happen? Both these hydrogens. Okay, now we are going to treat it with 2 moles. So CCH5, CH2N, CH3, and CH3. So what we are going to get? NN dimethyl, NN dimethyl, phenyl. Okay, methenamine. Methane amine. So this is the, like this we are going to find the products. Okay, so what we have done here, we have treated with 2 moles. So what is happening? Both the hydrogens are replaced by the methyl groups. Both the hydrogens are replaced by what? Methyl groups. Okay, fine. So next is a very important name reaction, that is Gabriel thalamide synthesis. Okay, Gabriel thalamide synthesis. Okay, we'll see this one. Name reaction, very important. Mark this for 2 marks. Important, mark this important for 2 marks. Very important. Okay, so Gabriel thalamide synthesis. Okay, so this also is used. So this is the what you say uh, method of preparations for only aliphatic primary amines. So from this we can use only aliphatic primary amines. Okay, we can prepare only aliphatic primary amines. We cannot prepare uh, aromatic amines. We can only prepare aliphatic primary amines. Okay, so what is the reaction? So we are going to take what? We are going to take a thalamide. So this is a thalamide compound. Okay, in the first, what you can see, this is a thalamide compound with a benzene ring, and this is a thalamide. So this is completely, it is a thalamide compound. So this thalamide, we are going to treat it with what? Alcoholic KOH. Okay, we are going to treat it with alcoholic KOH. So our KOH is prepared in alcohol. What is happening here? Your hydrogen, whatever the free hydrogen is there, it will be replaced by the potassium salt. It will be replaced by what? It will be replaced by our potassium salt. Okay, it will be replaced by the potassium. So this, what we get a potassium thalamide. Okay, so our hydrogen is replaced by K. So the rest all the compound will remain same. You are going to get what? Potassium thalamide. So this potassium thalamide, now further what we are going to get? We are going to treat it with the alkyl halide. So which alkyl halide we have used? We have used a ethyl chloride. Okay, which alkyl halide we have used? We have used a ethyl chloride. Okay, so this is the alkyl halide. I can take it like this. I can show you as Rx. So we are going to take now what will happen? Whatever the potassium is there, K is there. So that will be replaced by your R group. So which is the R group? Your CH3, CH2. So what I'm going to get? NC2, CH3. Okay, NCH2, CH3. Now this, so we are going to get a N alkyl thalamide. So here we have got what? N ethyl thalamide. Okay, we are going to get a N-alkyl thalamide, and then we are going to do what? We are going to heat it. We are going to heat it. We are going to do hydrolysis, okay, in the presence of KOH, and we are going to get a primary amine. So this is the primary amine, and we are going to get a potassium thalate. Okay, we are going to get a potassium thalate. So this is the Gabriel thalamide synthesis. So in Gabriel thalamide synthesis, these are the method. This is a method of preparation which is exclusively used to prepare aliphatic primary amines. Okay, we are going to use only aliphatic primary amines. Is it clear? Is it clear? Okay, so let me show you. Okay, let me write and show you. So this is our. So you have to practice this name reactions. Okay, so this is our thalamide. Okay, this is our thalamide. So thalamide, I'm going to treat it with alcoholic KOH. So let me write the name. It is thalamide. Thalamide. Okay, this thalamide I've treated with alcoholic KOH. What will happen now? So rest all the compound will remain same. Our NH is there, right? So that will be replaced by K. So this will be N minus. This will be K plus. So this will be what? This will be uh, potassium thalamide. Okay, so this is a potassium thalamide. So potassium thalamide. Okay, now further we are going to treat it with the alkyl halide. So we are going to treat it with the alkyl halide, and what we are going to get? Our C double bond O, C double bond O, and N and R. Okay, so what is happening here? Our this is a no K. K is replaced by the R. Okay. Now we got what? N alkyl thalamide. What we got? N alkyl thalamide. Now this N alkyl thalamide. Again, what I'm going to do? I'm going to treat it with alkyl KOH only. Okay, I'm going to do hydrolysis, base hydrolysis. So let me take KOH in the presence of water. Okay, what I'm going to do, I'm going to take a primary amine and plus I'm going to get a potassium thalate. Okay, I'm going to get a potassium thalate. I'm going to get a potassium thalate. Okay, so potassium thalate and primary amine. So this was a general reaction. Okay, let me take, now I'll give you an example. Let me give you an example. So I'll change in this one. Okay, so thalamide will remain same, alcoholic KOH will remain same. So potassium thalamide will remain same. Okay, up to this it will be same. What will be the difference? I'm going to take one alkyl halide. So let me take a ethyl halide. Okay, let me take the ethyl chloride. So what will happen? Our R will be what? Our R will be your now ethyl group. That is C2H5. Okay, it will be C2H5. So what will be the name? The name will be N-ethyl, not alkyl. It will be N-ethyl thalamide. Okay. Now again, what I'm going to get here. So what will be our after hydrolysis? We are going to get a primary alkyl and potassium thalate. Right. So this potassium thalate will remain the same. Okay. So this is a side product. What you can say. What we are going to get your R will be your ethyl group. So we are going to get a ethyl amine. What we are going to get a ethyl amine. Okay. Ethanamine. Is it clear? Is this reaction clear? Is this reaction clear? One more example I can take. Instead of alcoholic KOH, I can take NaOH. Okay, instead of alcoholic KOH, I'll take NaOH now. Now what will be the changes? So instead of K, potassium salt of thalamide, I'm going to get a sodium salt of thalamide, Na plus. Okay, so what will be the name? It will be sodium thalamide. It will be sodium thalamide. So instead of alcoholic KOH, now I'll take NaOH. Now, alkyl halide. So let me change the alkyl halide also. Let me take a methyl chloride. Let me take a methyl chloride. So instead of N-ethyl, this thalamide, I'm going to get N-methyl thalamide. Okay, what will be the name? N-methyl thalamide. Okay, N-methyl thalamide. Now, I'm going to do hydrolysis with what? NaOH in the presence of water. Okay. So NaOH in the presence of water. What will be my product? Can anybody tell me what will be the product? So there will be change in the product. Yes, tell me the product. What will be the product, students? It will be methanamine. Okay, CH3NH2. And what will be this? It will be sodium thalate. Okay, it will be sodium thalate. So depending upon what you are taking, okay, so you have to change. Is it clear? Any doubts up to here? Yes, anything? Okay, fine. So these all the name reactions you have to practice today. Okay, before proceeding. So we have completed the physical properties also in the last class. Okay, so we have to start with chemical properties. So chemical properties, we will start in the next class. Okay, so we will start the chemical properties in the next class. Any doubts up to here? So please go through the things whatever I have told. So we have completed the classification part. We have completed the IUPAC nomenclature. Then we have completed the physical properties, right? Then structure of amines and preparations of amines. So important things we have discussed. So which are the name? Which you have to practice preparations. Hoffman bromide degradation reaction and Gabriel thalamide synthesis. Okay, so these both the name reactions are very important. So other name reactions are also important, but these are compulsory asked questions. Okay, these are some of the questions which are compulsory asked during your finals. Okay. So in the next class, tomorrow's class, we'll be discussing about the chemical properties of amines. Okay, so basic characters of amine, and basicity and all. So these all things we'll be discussing in the next class. Okay. So any doubts up to here? Others? Okay then. So I'll be ending the session here. Okay. So we'll meet in tomorrow's class. Thank you. Have a good day.